Welcome to Quick Solutions All India AIATS Test Series JEE Main 2020 Test 5, which was held on 1st December 2019. Let's start. Question number 51. The locus of complex number z on Argand plane given by mod of z minus 1 minus iota is equal to mod of z sine of argument of z is a conic whose length of lattice rectum is. So there is two ways to solve this type of questions. First, you have to convert z into x plus iota y, then convert it into coordinate geometry. And another method is by using geometry. So see, suppose there is a point z, and here you can see this is written like 1 plus iota mod is equal to mod of z sine of argument of z. So this length OA represent modulus of z, and this angle theta is called argument of z. And suppose 1, 1 point lies something here, 1, 1. So z minus 1 plus iota. Suppose this is point B. So this length is represented by mod of z minus 1 plus iota. And this length is modulus z. So this perpendicular AM is equal to mod of z sine theta. So you can write like mod of z sine theta, you can write argument of z. So this is given mod of z minus 1 plus iota is equal to mod of z sine of argument of z. So basically locus of z is a parabola, because locus of a parabola, it says that its distance from a fixed point and its distance from a line is always equal. So locus of z is a parabola whose foci is 1, 1 and x-axis is a directrix. Now question is asking length of lattice rectum. So you know, suppose this is standard parabola, this is directrix, and this is foci for y is square equal to 4ax, and this line is x plus a is equal to 0. So the perpendicular distance on the directrix from the foci is equal to 2a, and length of lattice rectum is 4a. So here length of lattice rectum is equal to 2 times of bn. So this distance is 1, length of lattice rectum is 2. So option number 1 is your correct answer. Now move on next question. Question number 52. Let f of y is equal to 2y cube plus y plus cos y. For all y belongs to real number, then number of distinct real roots of the equation 1 upon x minus f of 11 plus 1 upon x minus f of 12 plus 1 upon x minus f of 13 is equal to 0. This is a very tricky question. See, f of y, if you substitute y as 11, so 2 into 11 to the power q plus 11 plus cos 11. So this value is always positive. Similarly, f of 12 and f of 13 are always positive. So f of 11, f of 12 and f of 13 are positive values. Now you have to find out the number of solution of this equation. So just assume this as gx. So if you find out value of g0 is equal to minus 1 upon f of 11 minus 1 upon f of 12 minus 1 upon f of 13. So you can see it is very clearly g0 is your negative number. Clear? Now if you take LCM of this equation, then you will get fx minus f of 11 x minus f of 12, x minus f of 12, x minus f of 13 plus x minus f of 13, x minus f of 11 is equal to 0. So this is a quadratic equation where coefficient of x square is always positive. So this is a upward parabola, and you have seen that value of g0 is negative. So it is very much clear this equation has two real roots. So your answer is option number 3. I hope you understand this question. Now move on next question. Question number 53. Let the equation ax square plus bx plus c is equal to 0 has two real and distinct roots in the interval 2 to 4 and a plus c is less than b, where a, b, c belongs to real numbers. Then question is saying this equation has two real and distinct roots which lies in the interval 2 to 4, and one extra information is this: a minus b plus c is negative. Suppose you have function f of x is equal to ax square plus bx plus c. If you substitute x equal to minus 1, then you will get a minus b plus c, which is negative. So just draw the graph. F of minus 1 is something here because this is negative value, and your roots lies between 2 to 4. So you have two options. It can be like this. In this case, f of minus 1 is positive, but you are getting f of minus 1 is negative. So this is very much clear. Your given quadratic equation is something like this. So you can see here f of 0, which is always negative. So c is always negative. So option number 2 is incorrect. No. Your parabola is downward. So coefficient of x square is always negative. So see, option number 1 is also incorrect. Now f of 1, which is always negative. So f of 1 is a plus b plus c, which is negative. So option number 3 is also incorrect. Now you have to tell about b. So see, the coordinates of vertex is minus b by 2a, comma minus d by 4a. So minus b by 2a is always positive. So you know a is always negative, so b should be positive. So option number 4 is your correct answer. Now move on next question. Question number 54. The coefficient of x to the power 16 in the expansion of 1 minus x to the power 10 x plus 1 upon x plus 1 to whole power 9 is 1 minus x to the power 10. Just write down x square plus 1 plus x to the power 9 divided by x to the power 9. So you have 1 minus x, 1 plus x square to whole power 9, 1 minus x divided by x to the power 9. You can see clearly this is 1 minus x cube to whole power 9, 1 minus x divided by x to the power 9. You have to find out coefficient of x to the power 16 in this. So now coefficient of x to the power 25 in 1 minus x cube to whole power 9. Now coefficient of x to the power 25 in 1 minus x cube to whole power 9 minus coefficient of x to the power 24 in 1 minus x cube to whole power 9. So see, 1 minus x cube to whole power 9, TR plus 1 is equal to 9CR minus x cube to power r. If you required coefficient of x to the power 25 in this equation, so 3r should be equal to 25, but from here you are getting 25 by 3, which is not correct for r. So coefficient of x to the power 25 in this expansion, which is 0, minus. Now you have to find out coefficient of x to the power 24. So just substitute 3r equal to 24, so r equal to 8. So coefficient of x to the power 24 is 9c8 minus 1 to the power 8. So you are getting minus 9. So option number 3 is your correct answer. Now move on next question. Question number 55. Consider the expansion x square plus x minus 1 to whole power 10 is equal to a0 plus a1x plus a2x square plus dot 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 plus 820x to the power 20. Then you have to find out the value of a0 plus a3, a18. So first of all, just substitute x equal to 1. So you will get 1 plus 1 minus 1 to whole power 10. So 1 is equal to a0 plus a1 plus a2 plus a3 plus dot 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 up to a20. Now substitute x equal to omega. Then you will get omega square plus omega minus 1 to power 10. And you know omega square plus omega is equal to minus 1. So from here you are getting minus 2 to the power 10. So basically this is 2 to the power 10 is equal to a0 plus a1 omega plus a2 omega square plus a3 omega cube, that is equal to 1 again, and so on, plus a20 omega to power 20, that is equal to omega 18 into omega square, that is equal to omega square. So omega square. Now substitute x equal to omega square. So if you substitute omega square here, to omega to power 4, that is omega plus omega square minus 1 to whole power 10. Again you are getting minus 2 to the power 10. So which is equal to 2 to the power 10 is equal to a0 plus a1 omega square plus a2 omega to power 4, that is equal to omega again, plus a3 and so on, plus a20 omega square to power 20, that is equal to omega. Now add all these three equations. So you will get 1 plus 2 to the power 10 plus 2 to the power 10 is equal to 3 times a0 plus a1 plus a1 omega plus a1 omega square. If you take a1 common, then you will get 1 plus omega square, that is equal to 0. Similarly for a2 you will get 0. So you will get here a0, a3, a6, all the multiples of 3, and the last you will get a18. So according to the question, you have to find out the value of a0 plus a3 plus a6 up to a18, which is equal to 1 plus 2 into 2 to the power 10. And you know 2 to the power 10 is equal to 1024. So 1024 divided by 3, which is equal to 683. So your correct answer is option number 1.